Hello, we are going to talk about more instance methods in this video and specifically the setters and getters. So, so we have a class definition and then which sets up make, model, year, and all that. And then we can actually have some code that does this interesting thing, and particularly this line. That maybe, hey, I want to say set the price for a car to a negative number so that not only I get a free car, I can actually get some cash along with the free car. Now, if we run this, yeah, absolutely, that works. Python totally allows that. Okay. Now, this example kind of, before we dive into a little more kind of discussion about this, there's something to kind of to recognize here that this, the definition for a car, this is kind of, this is the implementation for a type of data, right? And then this is using the definition for the car. Okay, now these two pieces of code, more often than not, they may be written by different people, right? There's the implementation, there's the designer and the implementer of a class, and then there's the client or the user of the car class. Okay, so that's what there's two type of programmers involved in code like this. And what happened here is that the client or user is directly accessing the instance attributes. What's the problem? I mean, other than what we've already covered before. The problem that results from the client and the user of the class being different from the designer or the implementer of the class is that the client or the user can be evil, right? Like in the example that I just showed, they're trying to get a free car and free cash. Or they can be just kind of, they don't know what's going on, or they are not careful, and they can potentially change some of the attributes to bad values. And then finally, and that's actually the most common reason or the common characteristics of these group of programmers is that they do not want to know. They do not want to be burdened with all the implementation details of the class, right? They just want to be able to use the class and store information and get information out. So they don't want to know how it works as long as it works the way that they want it to. So, but of course, they still want to know if they do something wrong, right? If they put some bad values in the attributes. So now, as it turns out, this is an interesting thing. Python does not care about the programmer or evil programmer. And I'm going to talk a little bit more about that at the end of this video. But the Python does, or not just Python, but programmers in general should at least care about the last two problems. And to address them, instead of allowing or instead of having the client code to access the attributes directly, we can provide instance methods to access the attributes. And then with methods, we can do something smarter. Okay, and so I'm going to show you how to do that. Now, what do we want to do with these instance attributes? Well, there are really two things we want to do. We want to read them, and we want to either create them or change them. So reading them is kind of a let's get the attribute, right? And that's kind of a right-hand side operation. So we use these things that are called getters. They get attributes. There are times that they are referred to as accessors. That's actually what the reading refers them to as. I just like the term getters. It's just so much easier for me to say it. It's a simpler word, right? And then to actually write them, change them, or to set them, we use what I call setters. In the readings, they're commutators. Again, I like the simpler term setters. So we're going to write getters and setters. We're going to start with the setters because they are more complicated. So what are setters? So setters are just instance methods that allows us to set some attributes. So let's write a method that allow us to set the price. Now, obviously, the client of the class should provide us with a new price to set, right? Otherwise, what are we setting it to? So we take a price. This method takes a parameter price, and then we just remember that price in there in our attribute. Okay, so very simple. So yeah, right. So yes, I do have to mention this is the methods, the naming style should be snake case, just like functions. And by convention, the setters, the way their name is, they set and an underscore and the name of the attribute. Okay, so if we're setting the price, we say set price. Just that. And the next thing is something that I've again, you're getting, I think you might be getting tired of what I've been saying about this, but the first parameter of an instance method is the instance on which the method is called. So we call this self, although you can call it other things. So this is the instance whose attribute we want to set. And obviously, the parameter price is the new value that we want to store in the instance attribute. And yeah, and then we have this assignment operation, right? Okay, how do we invoke it? We can invoke it by saying car dot set price, and then sure, let's set it to -1,000. Okay, so when we run this, it's still doing exactly the same thing. Nothing much has changed. Yes, again, this parameter self is automatically assigned the instance. Okay, and 1,000 or the -1,000 is assigned to this parameter price. That's how we call a method. Okay, now what we just did, it did not prevent the price being set to a negative number. So we said that's something we probably should want to do, right? So we should verify what a setter should do. A very common job for the setter is to validate the new value to make sure it's valid. So we can say, okay, if the price is less than, so let's say the minimum price is $1. It's a pretty cheap car, but anyway, I'll say, so we don't want it. We don't want a free car, and we obviously don't want to give out cash with a free car. So it should not be 0 or negative. So if it's less than 1, okay, we're not sure what to do just yet. So let's say pass. Okay. So and then, well, we really should. Okay, we really should kind of put an else if it's if this is when it's invalid, and then this is when it's valid. right? But we're going to do something here that will make it unnecessary in a moment. So, okay. So this is what we're trying to do, right? We check if it's bad, what do we do? And then if it's good, then we just set the attribute, right? So when it's very common that if it's a bad value, we want to return false in a setter to tell the client code that something is wrong with the price. So false means something's wrong. Then you would kind of think, okay, well, if everything is good, then we should return true, right? Now, this is by no means like the only way to do it, but this is kind of a common technique, okay? Common practice, let's say, so that the client have a chance to know if something's right or wrong. Now, instead of okay, well, so instead of doing this, let's actually use the setter, and I'm going to use it in a way such that I know whether the price has been set successfully or not, right? So if I set it to 1,000, I would expect the price, setting the price to be successful. Okay, so let's run that, and hopefully it works there, right? If it's 1,000, the price is set to 1,000. And we can actually print it back out and make sure it is 1,000. Oh, well, sorry, I haven't written the get price. I haven't written the getter yet. I apologize. But yes, okay, so all right, let me change the price to negative 1,000 now, and hopefully we'll see that it actually failed. Okay, so it failed. So that's the setter is validating the input. Okay. Another thing is when you see the number 1, the literal integer 1, that should kind of hopefully set off an alarm now, that because this really should be a constant, right? The minimum price for a car should be a constant so that we can adjust it, right? 1 is actually not a very reasonable minimum price for a car. We could make a global constant here. Let's say min price equal to 1. Okay, but when you think about this, the minimum price for a car really only makes sense in the context of a car, right? It doesn't have to be global. It can be part of the car. So instead of making it global symbolic constant, I'm going to make it part of the class. And there. So I put it in the class. It's indented, so it's part of the class. And now I define a class constant. And I can use that by, well, I cannot just say min price because it's no longer at the global scope. So in order to access a class, this is called a class attribute. In order to access a class attribute, I have to start with the class, dereference it, and then there. It will be able to get to the attribute min price using this syntax. Okay, so we do the same thing here. Yeah, nothing should have changed. And that's what I just did here. So when you define something at the class level, when you define an attribute, not using self and just in one indentation level deep as part of the class, that's called a class attribute. and we access the class attribute by starting with the class dot and then the name of that attribute. Okay, and we're going to have a lot more to say about class attributes later, but I just want to put this out here so that we at least have an idea of how to define constants for in the context of a class. So now that's so much for the setter. Now let's define the getter. Getter is a lot simpler. So define get price. Now getter doesn't need any parameters. It does not, because it's just all that is doing is it returns the attribute. Okay. So what a getter is that getter's naming convention. Okay, just like a setter. But instead of set, it's get, right? Get underscore and the name of the attribute. So when we want to get the price, we call it get underscore price. It doesn't need any input parameters, but as always, it's an instance method. So the first parameter is always the instance, and then all it does is return the appropriate attributes. And then now we can finally call it here. So what I type here is I'm just retrieving, instead of getting the dot price directly, I say get price. Okay, so now actually, so let me actually change this to positive 1000, and yeah, when I run it, because we successfully set 1000, when we get it back, we should see 1000 using the getter. Okay. All right, time for you to write some code. So let's write a setter and a getter for the model attribute of the class car. For this model attribute, there's no need to really check for anything in the setter because there's so many different models, and you can just set the model attribute and just return true. And then in your client code, you should use the setter and the getter to verify that they work properly. All right, so go ahead, give this a try. Okay, assuming you have done that, it should be very straightforward. I have something slightly more challenging for you. Write setter and getter pair for the make attribute. Now, in this setter, let's do something a little more elaborate. Let's make sure the new value for make is either Honda or Tesla. I know there are more than just these two brands in the world, but for this exercise, we can assume those are the only car brands around. And then you should return true if the new value for make is either Honda or Tesla, and you can return false if it's neither of them. And again, you should in the client code, you should test it. Okay, all right. Assuming you've done that, I've actually shown the code here. Not that it's any particularly difficult or anything, but I just want to show an example again. In this set make, that takes a new make parameter. We're checking to make sure that if this new value, if it's neither Honda nor Tesla, we return false because we say, those are the only two brands in the world. Apologize again if you disagree with that, but again, this is only for the sake of the exercise. And then if it passed the validity test, we'll remember the attribute, and then we return true. And then the getter is very simply just returning the attribute, the self.make attribute. And here is yet another exercise for you. We can get very elaborate with validity checks in setters. So here, let's write a setter and getter for the year. Okay. Now in the setter, if the make of the car is Honda, you should make sure the year is greater than or equal to 1963. I think I looked it up in the Wikipedia, and that's the first year that Honda made a car. If the make of the car is Tesla, make sure the year is greater than or equal to 2008. That is the first year that Tesla made a car. Okay, and you could optionally cap the maximum year to the current year, but then that would kind of make your program not very future-proof because the current year keeps increasing, right? Anyway, so go ahead and give this a try.